Find the angle between the tangents drawn from P 3, 2 to the circle x square plus y square. So, from an external point P, if two tangents are drawn, then what is the angle between the tangents? Tan theta is equals to r by root s11. So, given that P x1 comma y1 is equals to 3 comma 2. So, circle S x square plus y square minus 6x plus 4y minus 2 equals to 0. So, the center of this is minus g minus f. So, change the sign and the half of the x coefficient. So, 3 minus 2. So, and what is the radius? R is equals to square root of g square plus f square minus c. So, g square is 3 square 9, 2 square 4, minus of minus, so plus 2, which is root 15. So, root 15. Now, what is root S11? So, what is root S11? The length of the tangent drawn from P to the point where it meets or touches the circle. So, this is root S11. Similarly, this is also root S11 because this is A, this is B. A and B are the points of contact. So, the distance from the external point P to the point where where the tangent meets the circle, that is the point of contact. The distance between P to the point of contact is the length of the tangent. So, root S11 is equals to square root of x1 square plus y1 square minus 6x1 plus 4y1 minus 2. That is equals to x1 square 3 square, this 3 square 9, 2 square 4, 6 3s are 18 plus 4 2s are 8 minus 2. So that implies 9 plus 4 13, 13 plus 8 21, minus 18 minus 2 plus minus 20, 21 minus 20, which is root 1, that is 1. So if theta is the angle between the tangents drawn through an external point P x1 y1 with respect to circle S is equals to 0 is tan theta by 2 is equals to r by root s11. So that is equals to radius is root 15, s11 is 1. But this is not the answer because so if I join here, then this is the whole is theta and this is theta by 2 and this is theta by 2. So theta by 2, angle theta by 2 we get. And for obtaining the whole angle theta, we have cos 2 theta is 2 tan theta by 1 plus tan square theta, right? So sorry. So we have cos 2 theta is equals to 1 minus tan square theta by 1 plus tan square theta. So cos 2 theta in terms of tan theta, we have many formulas for cos 2 theta, which is cos square theta minus sin square theta, 2 cos square theta minus 1 minus 2 sin square theta, and another formula of cos 2 theta in terms of tan theta is this. So then what is cos theta? If cos 2 theta is this, what is cos theta? Half angle. If it is 2 theta, here theta, it was half here. So if it is cos theta, 1 minus tan square theta by 2 by 1 plus tan square theta by 2 modulus. So this is equals to 1 minus tan square theta. Tan theta by 2 is root 15. So tan square theta is minus 15 by 1 plus tan theta by 2 is root 15. Tan square theta by 2 is root 15 whole square, 15. So 1 minus 15 is, if theta is the acute angle, it will be minus. If I take a modulus, 1 minus 15 is minus 14 by 16. So this is 7 by 8 cos theta. So therefore, theta is equals to cos inverse, according to the inverse trigonometric function. Cos theta is 7 by 8, then theta is equals to cos inverse 7 by 8. The next question is, find the angle between the tangents drawn from 0, 0 to the circle. So earlier first question is, some 3, 2 is given, here origin is given. The process is not going to be changed. Given point is Px1, y1 is the origin and circle I have written. So the center of this is, again I am telling you, minus is there, you write its opposite sign, and the quotient of x is half, so that is 7. So here plus is there, minus you write, y coefficient is 2, half of that 2 by 2 is 1, so minus 1. Radius is g square plus f square minus c, 7 square 49, 1 square 1, minus 25. So 50 minus 25, root 25, which is 5. And what is root S11? Length of the tangent drawn from P to this circle. So S11, root S11, square root of x1 square plus y1 square minus 14x1 plus 2y1 plus 25. So x1, y1 being 0, 0, 0 square, 0 square, 14, 0, 2 into 0 plus 25. So root 25 is 5. So if theta is the angle between, theta is the angle between these two tangents drawn from P to the, with respect to the circle. So if theta is the angle between the tangents drawn through Px1, y1 to, with respect to circle as equals to 0, then tan theta by 2 equals to r by root s11. R we have, root s1 we have. So 5 by 5 is equals to 1. So cos theta is, cos theta in terms of 1 minus tan square theta by 2 by 1 plus tan square theta by 2. So 1 minus tan square theta by 2 is 1 square. So 1 plus 1 square. So 0 by 2. So cos theta is 0. Then theta equals to pi by 2. That means these two are perpendicular to each other. These two tangents are perpendicular to each other. Like this. The next question is, find the locus of P if the tangents drawn from P to x square plus y square equals to a square include an angle alpha. This is the standard equation of the circle whose center is at the origin. And this is R. And this radius and tangent are perpendicular to each other. So from P, two tangents are drawn. A and B are the points of contact, and these are the length of the tangents. So, and in the place of theta, alpha is the included angle now. So this is what is the data given. So he's asking, find the locus of P, not only this P. So there are so many tangents are drawn from the external point. For example, this is a circle, and from this point P, two tangents are drawn. So this P is, for example, here now. So from this, two tangents are drawn. This time, for example, P is this. So from this point, external point, two tangents are drawn. So that means the behavior of this is the locus of P. So that behavior of P, the locus of P is what we are required to find. Okay. For this solution, so we have already a formula. What is that? If alpha is the angle between the tangents drawn from Px1y1 to, with respect to the circle s is equals to 0 is tan theta by 2 is equals to, here theta by 2, alpha by 2 is equals to r by root s11. So here what is r? R is the radius of the circle, so r is equals to a, and what is root s11? Square root of x1 square plus y1 square minus a square. So very first and foremost, let Px1 y1 be the locus of P will take. Now tan alpha by 2 is equals to, radius is a by square root of s11 is x1 square plus y1 square minus a square. So tan alpha by 2 is this we got. Now since alpha is the included angle, what is cos alpha? 1 minus tan square alpha by 2 by 1 plus tan square alpha by 2. 1 minus, what is tan square alpha by 2? A square by x1 square plus y1 square minus a square by 1 plus tan square alpha by 2, a square by x1 square plus y1 square minus a square. This is cos alpha is equals to. So that implies cos alpha is equals to, so x1 square plus y1 square minus a square by x1 square plus y1 square minus a square by, this is numerator, denominator is x1 square plus y1 square minus a square plus a square by x1 square plus y1 square minus a square. So both these denominators will be cancelled. So that implies cos alpha is equals to x1 square plus y1 square minus 2a square by, this and this gets cancelled, x1 square plus y1 square. So cross multiplication, x1 square plus y1 square into cos alpha is equals to x1 square plus y1 square minus 2a square. So that implies this minus 2a square, if you bring here, 2a square is equals to x1 square plus y1 square into this x1 square plus y1 square into cos alpha, if you bring to that side, x1 square plus y1 square minus of x1 square plus y1 square into cos alpha. So if you take this to be a common factor, then 1 minus cos alpha we are getting here. So this is equals to x1 square plus y1 square into, what is 1 minus cos alpha? 2 sin square alpha by 2, because 1 plus cos 2 alpha is 2 cos square alpha. 1 minus cos 2 alpha is 2 sin square alpha, the half angle. 1 minus cos alpha is 2 sin square alpha by 2. This will learnt in the first year trigonometry. So that is equals to 2a square. So this 2 gets cancelled. So therefore x1 square plus y1 square is equals to a square. This sine square alpha by 2, if you bring here by sine square alpha by 2, it will be cosecant square alpha by 2. Therefore, the locus of P is x square plus y square is equals to a square cosecant square alpha by 2. The similar kind of question, find the locus of P, the locus of this point. Let P x1 y1 be the locus. If the tangents drawn from P to the circle x square plus y square is equals to r square are perpendicular to each other. If it is perpendicular to each other, we need to find out the equation of the locus of P. So similarly, if theta is the angle between the tangents drawn from an external point, so tan theta by 2 equals to r by root s11, r equals to a, root s11 is root of x1 square plus y1 square minus a square, the length of the tangent drawn from px1 y1 to the circle. So px1 y1 is the locus. So given that, since the tangents are perpendicular, since the tangents are to be perpendicular, theta is equals to 90 degrees. That implies tan 90 by 2, 45 degrees is equals to r value is a by root s11 value is root of x1 square plus y1 square minus a square. So tan 45 is 1 is equals to a by square root of x1 square plus y1 square minus a square. So cross multiplication we get square root of x1 square plus y1 square minus a square is equals to a square. So squaring on both sides, x1 square plus y1 square is equals to 2a square. Therefore, the locus of Px1 comma y1 is, so simply remove x1 y1. Therefore, the points behavior in this plane we will be getting. So is x square plus y square is equals to 2a square. That means, so following the two tangents to be perpendicular, there would be so many points from this point P. Two tangents are drawn, and this is perpendicular. This is P1. From this point, two tangents are drawn, and this is perpendicular to each other. This is P2. So likewise, if I join all these points, so that represents x square plus y square equals to 2a square. So if I join all these points P3, P4, etc. So from this point, draw two tangents which are perpendicular to each other. So if I join all these points, then the circle is formed. So therefore, the behavior of this point P in this plane is a circle. The next question is, find the slope of the polar of 1, 3 with respect to the circle. Also find the distance from the center to it. So, P1, 3 is an external point. So, this is the circle. If the pole P lies outside the circle, polar cuts the circle at two distinct points, right? So, this is the polar equation. So, solution, given line equation is, given given equation of the circle is S, x square plus y square minus 4x minus 4y minus 4 equals to 0. So the center of this is minus, the opposite sign of minus is plus. So half of the quotient of x, 4 by 2, 2 comma 2. Okay, and so the equation of the polar of Px1y1 with respect to circle s is equals to 0 is s1 equals to 0, implies xx1 plus y1 plus minus 2 into x plus x1 minus 2 into y plus y1 minus 4 equals to 0. This implies, so x1 y1 value is 1 comma 3. So p x1 y1 is equals to how much? 1 comma 3. Now, so 1 into x plus 3y, y into 3 minus 2 into x plus 1 minus 2 into y plus 3 minus 4 equals to 0. X minus 2x is minus x, 3y minus 2y is plus y, minus 2 minus 2 3s are minus 6, minus 2 3s are minus 6, minus 4 minus 10, minus 2, so minus 12 equals to 0. So therefore the equation of the required polar is, if you take minus as a common, so x minus y plus 12 equals to 0. Slope of ax plus by plus c equals to 0 is m equals to minus quotient of x by coefficient of y. So that is minus x quotient is 1 by y quotient is minus 1. So this is 1. Now the slope we have found, and further he is asking to find the distance from the center to it. Center to it means polar. So this is the line. What is this line? X minus y plus 12 equals to 0. So what is the distance from the point P x1 y1 to the line? Point and line. So distance is modulus of perpendicular distance ax1 plus by1 plus c by square root of a square plus b square. So the perpendicular distance from P x1 y1 to the line ax plus by plus c equals to 0 is modulus of ax1 plus by1 plus c by square of the quotient of x plus square of the quotient of y. So that is, so the distance d is equals to, so let us suppose that this is the distance. This is the distance. So d is equals to modulus of, in the place of x, 2 minus, in the place of y, 2 plus 12 by square root of square of the quotient of x. So 1 square plus minus 1 whole square. So this is equals to 2 gets cancelled. 12 by, this is root 2. 12 can be written as 6 into 2 by root 2. So root 2 times. So 6 root 2 is the answer. The next question is, if ax plus by plus c equals to 0 is the polar of 1 comma 1. So let us suppose 1 comma 1 is the point with, this is the circle. So with respect to p 1 comma 1, what is the equation of the polar of p x1 y1 with respect to circle s is equals to 0? That is s1 equals to 0 for this. So one line equation we are going to get in terms of x, y and constant equals to 0. So this line according to the question is ax plus by plus c equals to 0. So it clearly says that this is the polar of 1 comma 1. That means 1 and 2 represents the same straight lines. So let us compare. So solution, given equation of a circle is S, x square plus y square minus 2x plus 2y plus 1 equals to 0. The center of this is C is equals to 1 comma minus 1. So given point is P x1 comma y1 is equals to 1 comma 1. So this 1 comma minus 1 is this center of the circle C, 1 comma minus 1. So 1 comma 1 is the point given. So equation of polar of P to with respect to circle S is equals to 0 is S1 equals to 0. That implies, what is S1 equals to 0 for this circle? Xx1 plus y1 minus of x plus x1 plus 1 into y plus y1 plus 1 equals to 0. That implies, what is x1 y1? 1 1. So x plus y minus of x plus 1 plus y plus 1 plus 1 equals to 0. This is equals to x minus x gets cancelled, y plus y, 2y. So minus 1 plus 1 gets cancelled plus 1 equals to 0. We can write it as 0x plus 2y plus 1 is equals to 0 also. So let us suppose this is 1. So what is the line? But given polar is given equation of a given polar line of 1 comma 1 is ax plus by plus c equals to 0. So this 1 and 2 represents the same straight lines because the polar of P x1 1 comma 1 with respect to the circle is this line. According to the question, the same line is the polar of this. So 1 and 2 represents the same straight lines. 1 and 2 represents same lines. So let us compare. A by 0 is equals to B by 2 is equals to C by 1. So all are equals to K. So from this, A is equals to 0 into K 0, B is equals to 2K, C is equals to K. So given that HCF of ABC is equals to 1. That means A square plus B square plus C square is equals to C square is equals to how much? So A square is 0 square plus B square is 2K square, 2K whole square, 4K square, and this is K square. So this is 5K square. So 5 into K value is 1 because HCF of all this is equals to 1. So therefore A square plus B square plus C square equals to 1. HCF of all this is equals to 1, that is equals to K. So A square plus B square plus C square is equals to 5. The next question is, if the polar of the points on the circle x square plus y square equals to A square, with respect to the circle x square plus y square equals to B square touches the circle x square plus y square equals to C square, then prove that A, B, C are in geometrical progression. Geometrical progression, we know that if ABC or in GP, B square equals to AC. So that is what we are going to prove. What is to be proved? B square equals to AC. If ABC or in AP, B square equals to AC is the condition. So this is what we have to prove ultimately. Now, there are three circle equations: x square plus y square equals to a square, x square plus y square equals to b square, and x square plus y square equals to c square. So what is happening is, solution, let p x1 comma y1, the polar of the points on the circle. So let p x1 y1 be a point on the circle x square plus y square is equals to a square. So that means whenever a point p x1 y1 lies on the circle, see here there are three circles, all of which has the center origin. These are three are the standard equations of the circle. This big circle is x square plus y square equals to a square. On that big circle, point lies. That point I have taken x1 y1. If a point lies on the circle, point has to satisfy the circle equation. That means x1 square plus y1 square equals to a square. Since p lies on the circle, implies x1 square plus y1 square equals to a square. Now, so the polar of the point with respect to circle. See, this is the circle and this is the point. So the polar of p with respect to x square plus y square is equals to b square is. So that's what the polar of p x1 y1 with respect to the circle with respect to s. With respect to the circle as x square plus y square equals to b square is, so this is the point p x1 y1, this lies on the big circle x square plus y square equals to a square. So this is p x1 y1, then the polar of this is this, okay, is s1 equals to 0, that is x1 plus y1 minus b square equals to 0. So, and if you go further, the polar is a straight line. The polar, that means this, touches the circle. The polar, this is the polar of p onto the circle x square plus y square equals to b square. So, this polar touches this circle. Clearly see, the diagram shows this line touches the innermost circle, which is x square plus y square equals to c square. Since this polar touches the circle x square plus y square is equals to c square, what is the condition of the tangency? R is equals to D. Radius is equals to perpendicular distance from the center of the circle to the line. So what is the radius of this? So the radius of the innermost circle x square plus y square equals to c square is R is equals to C, and D is equals to perpendicular distance from the center of x square plus y square equals to c square, that is 0, 0, because this is the standard equation of the circle, its center is 0, 0, 2. What is the line? Line is the polar. What is the polar? x1 plus y1 minus b square equals to 0. Again I am telling you, p x1 y1, I have taken this point on the outermost circle, which is x square plus y square equals to a square. If p lies on the outermost circle, p has to satisfy the equation. Therefore, x1 square plus y1 square equals to a square, point number 1. If P is a point, the polar of P with respect to the middle circle is the polar of P with respect to middle circle x square plus y square equals to b square is s1 equals to 0. So this is the polar. I got polar is a straight line. This straight line touches the innermost circle. So whenever a line touches the circle, this is the condition. R is equals to D. So this is D. So radius is equals to radius of the circle, innermost circle. What is the radius of this? C. D is perpendicular distance from the center of the circle. For all of them, C is 0, 0. So I will apply. So D is equals to modulus of xx1 plus yy1 minus b square. Perpendicular distance from point P x1 y1 to the line ax plus by plus c equals to 0. So x1 y1 is 0, 0. So x into 0, y into 0. So minus b square by square root of the quotient of x plus square of the quotient of y. x1 square plus y1 square. x1 square plus y1 square. So now R is equals to D is radius is C. C is equals to D is minus b square by square root of, what is the square root of x1 square plus y1 square? x1 square plus y1 square is a square. So square root of x1 square plus y1 square is a square. Square root gets cancelled. So AC is equals to minus b square under modulus is b square. So if AC is equals to b square, see. So this is the condition that we have to prove. If b square equals to AC, therefore A comma B comma C are in GP, geometrical progression. The next question is, tangents are drawn to the circle x square plus y square equals to 16 from the point. So from the point P, two tangents are drawn to the circle x square plus y square equals to 16. Find the area of this triangle. This triangle formed by the two tangents drawn from external point P to the circle. And what is this? If P is a point, then this is the chord of contact. So this triangle is formed by two tangents and chord of contact. So already before this, so let us deal this theorem. The area of the triangle, this is the triangle. So the area of this triangle is R into S11 whole power 3 by 2 by S11 plus R square, where R is the radius of this circle. So the triangle formed by what? By two tangents. And these tangents are drawn from the Px1 y1 exterior point of the circle to this exterior point of the circle. And what is AB? A and B are the points of contacts of the tangents drawn from P to the circle. Therefore, this point of contacts, if I draw a line, then this line is called the chord of contact. So this is the triangle formed by two tangents and one chord of contact. So proof: if theta is the angle between the tangents drawn from Px1 y1 to with respect to circle S is equals to 0 is, we knew tan theta by 2 is equals to R by root of S11. This we knew. So here area of triangle PAB is equals to half into, what is this theta? Theta is the included angle between the tangents PA and PB. So half into, so half AB sine theta, half AB the included angle, sine included angle. So likewise, half into PA into PB is into sine theta. So half PA is length of the tangent drawn from P x1 y1 to the circle S is equals to 0. So this is S11. So what is PB? Same S11. So half root S11 into root S11 into what is sine theta? So tan theta by 2 we know, then sine theta is, sine theta in terms of tan theta formula is 2 tan theta by 2 by 1 plus tan square theta by 2. So this is half root S11 into root S11 is S11 into 2 tan theta by 2 is R by root S11 by 1 plus tan square theta by 2 is R square by S11. So this is equals to 2 gets cancelled. So R into, see this root S11 will be cancelled in S11, root S11 times. So R into root S11 by, so this is R square by S11. So if you find the LCM, S11 plus R square by S11. So R into A by B by C, AC by B. So this S11 will go onto the numerator. So R into S11 into root S11 by S11 plus R square. So this is equals to R into S11 under root is S11 whole power 1 by 2. Here power 1. S11 whole power 3 by 2 by S11 plus R square. So using this, we will find this. See that the area of the triangle formed by the two tangents drawn from an external point P to the circle and the chord of contact AB is area of the triangle formed by the two tangents drawn from an external point P x1 y1 with respect to circle S is equals to 0 and the chord of contact of P with respect to circle S is equals to 0 is R into S11 whole power 3 by 2 by S11 plus R square. So radius is equals to 4 because x square plus y square equals to r square. R square is 16, r is 4. The standard equation of the circle whose center is at the origin. So S11 is the length of the tangent from P to S is equals to 0 is root S11. So that is equals to, okay, so root S11 is the length of the tangent otherwise, and S11 is x1 square plus y1 square minus 16 is equals to 0, S11. So that is equals to 3 square 9, y1 square 5 square 25 minus 16. So 9 plus 25 34 minus 16 8 18. Okay. So now R value is 4 into S11 18 whole power 3 by 2 by S11 is 18 plus R square is 4 square 16. This is equals to 4 into 18 is 9 into 2 whole power 3 by 2 by 18 plus 16 is 34. That is equals to 4 into a b whole power n, a power n into b power n. So 9 whole power 3 by 2 into 2 whole power 3 by 2 by 34. So 4 into 9 can be written as 3 square whole power 3 by 2. 2 gets cancelled. So 2 power 3 by 2 is 2 root 2 by 34. This is equals to 3 cube 27 2s 54 4s 216 root 2. Otherwise, so 3 cube 27 into 4 into 2 root 2 by 34. So 2 17s, right? So 2 2s are 4 27s. 108 root 2 by 17.